In case of function as a service, our idea is to develop microservice based cloud system and emulate the behavior of AWS Lambda. For this, we have set up a Docker Swarm on ThotoLab, and we are using this setup to demonstrate the same. So once the Docker Swarm is set up, you can see the nodes that are involved in it with this command. And we are on the manager node right now, and these are the three participating nodes which are present along with it. On the manager node, we have some set of services running. The first service would be the Flask app, which is the API gateway for the user to interact with. These are the public APIs that we expose to the user to uh, manage users as well as manage functions that they create and execute the function. This particular image is the Tomcat application, which is the DB manager. It houses all our internal APIs to talk to the DB, which is a Postgres database running on a manager node. Along with that, we also have a registry which contains the images for all our microservices, which can be deployed on demand when user sends us a request. Along with this, we have the Google C Advisor, and we have deployed Elasticsearch as well as Kibana on all the nodes, so that Kibana is set up on one of the nodes, whereas C Advisor is set up on all the nodes to pick up all the applications. So this indicates how, where, and how many number of replications of the applications present. When it's global, it is present on all nodes, and one would expect only one copy of the application to be present. So Kibana would give us an idea of what is the consumption happening on each one of those applications. So this is the Kibana UI, which shows us the network, the file system usage, and the memory consumption for the applications. We can see that as well as the memory for each node. So user can track how much computation resources are being consumed here. Once user has deployed a microservice, they can check that through Docker Service LS. So as you can see, there is a user create method which is being executed right now. So since if you want more details, you can go check it out through Docker Service PS, which will tell you on which node it's being run. So the manager has decided to run it in the manager node itself. So you can see the current status and how long has it been running for. And this is the image that has been pulled from the repository for running this particular microservice. So once this application now it has changed to one, that means that the application actually started running here, and after it has completed, the user would actually be created in the DB, and that can be accessed through the RESTful APIs that we have exposed. So as you can see, depending upon the resources that are currently present, the manager would shut down as well as restart the services until the application completes. So the possibility of it being shut down is dependent on the underlying infrastructure resources that it has. So, but it always allows us the guarantee that the service will be executed completely. So the original request that we are looking for is actually complete now. And similarly, when user wants an application to be deployed, they can use our endpoint REST APIs to trigger a request, and we will deploy the service accordingly. And the manager will see where the resources are available and allocate the service to that particular node, and execution will continue until the service is completed and user operation is done.